group is called ColdFront, and their project name is DogTags, so be ready for some cute pictures. I'm going to take you to a remote stream with Sam, who will be introducing the project.
Hi everyone, my name's Sam, and I'd like to introduce you to our team, ColdFront. ColdFront is myself, Paul, Lewis and Ben, and today we're going to share with you the result of all our hard work and collaboration over these last couple of weeks. We really have all found this to be an enjoyable, challenging and ultimately rewarding experience, and we're here today to demonstrate and present to you our app, DogTags. Often the apps that we keep on our phones are useful and help us to navigate everyday life, but sometimes apps are just for fun. You may use apps for learning useful facts, say, or storing your favourite photos. What about if you're a dog lover too? So now I'm getting a little bit specific, and this is because the audience that we imagine for our app includes just such a person. Someone who might very well be interested in using photo recognition to identify the breed of any dog they meet just by taking a photo. Our app allows you to take a photo of a dog and via machine learning technology to then evaluate the most likely breed of that dog. In addition to this, DogTags will send you interesting facts about the specific dog breed and incorporate these into a card along with your unique photo. DogTags allows you to store your collection of photo cards, so you'll have a history of all the different dogs you've met, photographed, and the information you've gathered. So I've told you a little bit about the app, but we would love you to see it in action. So I'm going to hand over to Ben, who's going to lead us into the demonstration.
Thanks, Sam. The inspiration for our app came from, well, dogs. What more do I need to say? Dogs are great. If there's any cat people here, then we best leave that argument for another time. I had loads of fun testing this app with my dog Arnie, who gets a starring role in the demo, so keep an eye on for that. We decided on this app because we like the idea of using machine learning and wanted to challenge ourselves with new tech that none of us had used before. We had seen apps that could identify other things, so we had the idea to build DogTags. We aim to get an accurate percentage return for the breed of dog and a list of characteristics for the dog. With that said, let's move on to our demo. When the app is loaded for the first time, the app will inform the user that it will need permission access to the camera and give them the option to allow or deny access. This is the home screen of our React Native front end, where we mount the camera component and display to the user a full camera preview and our navigation bar. The DogTags button on the right of the navigation bar shows our brand name, and when tapped, it displays some helpful information for the user about how to use the app. This is where we take the picture. Once taken, we see our loading screen. At this point, our TensorFlow.js image classifier is making a dog breed prediction based on the photo. The card then appears containing our picture, the prediction, a stock photo of the dog, and the characteristics of the dog. Stock photo and dog characteristics are retrieved from our mongoDB database using our Express API. There's also a delete button if there was a problem with the picture that was taken. We can tap the camera button to be taken back to the preview screen if there are more dogs we would like to take a snap of, or if we would like to get a better picture. Here, we can tap the history button to view a gallery of images that have previously been taken. In gallery view, we can scroll depending on how many pictures have been taken. Tapping on one of the pictures opens up the full card for that dog with the information that was previously stored. As you can see, navigation between cards in the gallery is fluid and makes it easy for the user to show off their pictures. If we decide to delete one of the cards, we can also do that here. So we hope you enjoyed our demo. I'm now going to pass over to Lewis to talk about the tech stack we used.
Thanks, Ben. So our mobile front end was written using React Native, using Expo. We decided to use Expo because the Expo SDK provides lots of useful libraries for doing things like accessing the device camera and accessing the device's file system, which was necessary for our app. We also use those technologies because Expo and React Native both have really excellent documentation online. TensorFlow.js is the machine learning library that we went with to implement the core image classification functionality of our app. This runs on our Express backend using TensorFlow's Node.js library. Using TensorFlow.js, we were able to start with an existing general purpose image classification model and then customize it customize it to our more specific use case. That was done through a process called transfer learning. We found that this was a relatively beginner-friendly approach to solving this kind of problem, which was suitable for our level of experience with machine learning. I'm going to now pass over to Paul, who can tell us a bit more about our tech stack and a little bit about our development process.
Thanks, Lewis. So we went with mongoDB for our database. It's a non-relational database that's hosted on the Mongo Atlas cloud server, and we decided to go with non-relational for a couple of reasons. So one is that it allows us easy updates to schemas and fields, but also our dog objects that we're storing in the database have no relationship with each other, so it seemed to be the best fit for our needs. A few of the, just to talk about a few of the challenges that we faced along the way. So firstly, we were going to load the do the classification of the dog image within our React Native front end. What we found though was that doing it this way would increase the size of our app too much, so more than we would have hoped for, and this was because we'd be loading the classifier data set within the front end, and also it would require us to install MobileNet on the user's phone. So we overcame this by moving that functionality into our backend instead, and we found that actually by doing so we weren't increasing the time taken from taking a picture to getting the prediction, so we were quite happy with that and that there was no impact on user experience. Another challenge that we faced was in communicating with MongoDB, in that we found that we couldn't directly communicate from React Native to the database. That was mainly due to the limitations of Expo and its compatibility with third-party SDKs. So what we did instead was we managed to use some of the experience that we learned during the back-end phase of Northcoders to set up our Express API to handle that communication for us. We set ourselves up to handle these challenges by doing quite a lot of spiking before beginning the project. This was really useful for us to better understand what tech options would be available to us and for our particular needs as well. We also incorporated a lot of agile working practices into our daily routines. So, for example, we would have a morning stand-up, regular meetings, and also a combination of pair and mob programming. And mob programming in particular helped us a lot during the beginning phase, where we found there to be some installation issues, but we managed to overcome the challenges that we faced. And in doing so, by using these practices, it really taught us just how valuable they can be. So what is the future for DogTags? We would like to scale the app up and implement some location services that would point the user towards rescue centres, local rescue centres, and also registered dog breeders. We think this would add a really great new layer to the app, because it would be beneficial for the dogs that are in these centres, and also provide a much more rewarding and rich user experience as well. And that's it. Thank you very much for listening.